Hello friends, today we solve a simple problem on this principal stresses. In the principal stresses there is two methods. One is analytical method and one is graphical method. So in the graphical method, the Mohr circle describes to calculate the principal stresses on the given problem. So this is the graphical one. In this, see the question. A body subjected to two mutually perpendicular stresses. One is sigma 1, 200 Newton per mm square, and one is sigma 2, 100 Newton per mm square. And the principal plane is acting on the major axis at the inclination of 30 degrees theta. So what we can find from here? Normal stress sigma n value and tangential stress sigma t, and resultant of the normal stress on the principal plane sigma r by using graphical method. In this method, first we assume any scale to convert the 200 and 100 Newton per mm square stresses to the smaller values for our comfortable to draw the Mohr circle. So I am assuming scale of 1:25. So it represents what? 1 centimeter on the graph represents the 25 Newton per mm square of the stress. For this we can convert the sigma 1 and sigma 2 values. So sigma 1 is equals to 200 by 25. It means 8 centimeters of length is present in the sigma 1. Similarly, sigma 2 is equals to 100 by 25. So how much? 4 centimeters. Next we can draw the Mohr circle by using these values. So now first take a baseline to draw the Mohr circle. So locate a point on the baseline which represents the A. From this reference point, first draw the sigma 1 to the right side of the point. How much sigma 1 is? 8 centimeters. So we can draw 8 centimeters from the right side of the A. So I am locating 8 centimeters of distance. This is sigma 1 value. Sigma 1 is equals to 8 centimeters. From this distance only, from the right of the A, we can locate the sigma 2 also. Sigma 2 how much? 4 centimeter. So exactly half of the sigma 1. So again we calculate the measure the sigma 2 value and locate it. And this is represented as B and this is represented as C. So in this line, CB represents the diameter of the Mohr circle. How much the diameter was? 4 centimeter. So locate the 2 centimeter point and draw the circle. So like this I am drawn the circle with reference to the diameter of C and B. So at the center point it was treated as O. So from the O point, next we can locate the point E on this Mohr circle. Thus point E should be in the value of 2 times of the theta. Theta is how much? 30 degrees. So 2 times of theta means 60 degrees. So by using protractor we can locate the 60 degrees point. I am directly locating and join it like this. This is the amount of 2 times of the theta, which is 60 degrees. This point is E. From the point E, locate the D point on the OB, which is perpendicular, which is clearly perpendicular to the OB. Like this. This is treated as D. Let's join the CE and AE. Like this I am joined the points AE and CE. So the CE represents the angle of theta with reference to the CB. By this we can measure the length of AD. Here AD represents the normal stress value and DE represents the tangential stress value and AE represents the resultant stress value. So these were directly calculated by measuring with the scale. So how much it was? from A to D it was 6.6, right? So sigma n is 6.6 centimeters. So how it can convert into the stress? 6.6 into 25. So it was 165 Newton per mm square normal stress. Sigma T. For sigma T, what we measure? The points D and E. So it was 1.7. 1.7 centimeters. So 1.7 into 25. 42.5. 42.5 Newton per mm square. Finally, distance AE. How much? It is nearly 7. So 7 centimeters. So 7 into 25. How much? 175 Newton per mm square. This is the problem. I am recap this fastly again. So first what to do? We can assume any required scale to draw the Mohr circle. I am assuming it as 1:25 and convert the sigma 1 sigma 2 values with reference to this scale. So sigma 1 200 by 25 means 8 centimeters, 100 by 25 means 4 centimeters. And next, now take the reference line and locate a point A on the line. From A, locate the 8 centimeter B point at a distance of 8 centimeter from A. And from A, right side of the A, locate the point C as the intensity of sigma 2, that is 4 centimeters. Now from C to B, draw the Mohr circle with reference to the C to B diameter and locate the point O, which is the center of the Mohr circle. From the point O, locate the E point on the Mohr circle with the inclination of 2 theta. And next join the OE and AE. Then finally measure the distance of AD, which represents the normal stress, and measure the DE, which represents the tangential stress, and measure the AE, which represents the resultant of normal stress. So I am measured 6.6, 1.7 and 7, and it will convert into the stress values with reference to our scale. So 6.6 into 25, 165 Newton per mm square, 1.7 into 25, 42.5 Newton per mm square, and 7 into 25, 175 Newton per mm square. This was the problem.